Hi guys. So today we're going to talk about the PV loop and just the basics of it. And so basically the PV loop is just a representation of what's going on in the heart while it's working. Okay? So the first thing you have to know is that from here to here, this is going to be the stroke volume. So this is the volume that that one ventricle is going to contract. So the volume of blood that one ventricle contracts into the aorta. Okay? And so this point here, so all along this line, this is going to be the end systolic volume, and along this line here, from point C to point B, or B to C, they're both the same. This whole line is the end diastolic volume. Diastolic means filling, systolic means contracting, basically. So at the end diastolic volume, so that means at this point in time, at this volume, that's the volume at which the ventricle fills. So once it's full, you can guess that the next step is to start releasing that blood, right? And so the end systolic volume would be after that volume gets released, whatever's left, that's the end systolic volume, because not all the blood gets ejected from the ventricle, some of it stays. So the difference between the end diastolic volume and the end systolic volume, that is the stroke volume. So you would just subtract. So whatever this volume would be here, you would subtract it from here. Okay? And then you'd be left with a number, and that's the stroke volume, or how much blood was contracted. Okay, so let's start. So starting with point A, we're going to work our way around to point D, and then back to A. And so this is just going to be step by step of how the volume and pressure changes and what's going on along these lines here. So starting with point A, what can you expect is the first thing that's going to happen? Well, the blood needs to fill the heart. So this is the rapid filling phase. So you have a rapid filling here, and we're moving this way, counterclockwise, all throughout the graphs. So I'll just put arrows there. And so we're moving this way. So rapid filling first into the atria, and then at this point the blood moves into the ventricles, and that's called diastasis. And so now the blood is in the ventricle and it's building up, but not all of it has gone into the ventricle, and so the last bit of blood that's kind of like left over, that in order for that blood to get into the ventricle, the atria need to contract. And so this is called atrial contraction here. Okay, so now the atria have contracted the rest of the blood into the ventricle. And so now we've reached point B. And so we're at point B, and this is the start of systole. Start of systole. So systole meaning the ventricle is filled and it's ready to contract and release the blood into the aorta. Okay, so that was step one. Step two is just going to be simply building up pressure, right? We're going from point B to point C. And if you look at the graph, all it is we're building up pressure. So the pressure is going up from point B to point C, and that's it. So this is called isovolumetric contraction, right? So we have the same volume, but higher pressure as we go up. And so now we're at point C. And so at point C, we've built up enough pressure that the valve between the ventricle and the aorta is going to open, and that's the aortic valve. And so here, the aortic valve opens. And that pressure that needed to be met in order to open that valve, that is called the afterload. So that's called the afterload. So the afterload has been met, the valve opens, And what can you guess the next part is? Well, the blood has to go through. And just like with the filling phase, it's rapid filling at first. And so the first part that's going to happen is rapid ejection, because now we're getting rid of the blood. We filled the heart with blood, and now we're getting rid of it so it can go back to the rest of the body. Okay, and so rapid ejection, and then it's still getting ejected, and then by the end of it, we reach a slower ejection part. Okay, so now the blood, most of it has been ejected into the aorta. And so now the valve can close. So the aortic valve, aortic closure. So now the valve closed, and now we can start filling again, right? Because we've gone to the aorta, and through the aorta it's going to go to the rest of the body. But now the heart's empty, and so it needs to be filled again. And so this is the start of diastole, or the filling phase. So D is the start of the filling phase. 3 was the ejection phase. And then 4 is going to be, in order for the heart to get filled, it has to relax. So this is the isovolumetric relaxation. Again, we're not changing volume, but we are changing pressure. We're going from a higher pressure to a lower pressure. We're going from D to A. Okay? And so this decrease in pressure allows the blood to fill the heart again. And again, this is the end systolic volume, right? Because when by the time we got to point D, the blood was ejected from the ventricle into the aorta. And so whatever volume we were left with, that was our end systolic volume.